Okay, so we're going to be looking at binomial experiments with word problems. We've been working with binomial experiments this unit, right? So now let's see. It says you are taking a multiple choice quiz test of 5 questions, only 5 questions. Each question has 4 possible answers, only one of them which is correct. Only one of which is correct. So okay, so before I continue reading, remember how we in binomial experiment we have a p-value and a q-value. Our p-value was the percentage that we're correct. And there's 4 questions. One of them is correct. So 1 out of 4, I'm going to call it 0.25. Probability that I'm correct, randomly correct on each question is 0.25. Well, what's the probability that I'm wrong? Well, 0.75. That's for each of my questions. Remember, there's 5 questions. Now, let me continue reading. To complete the quiz, you randomly guess the answer to each question. Find the probability of guessing part A, exactly 3 answers correctly. Part B, at least 3 answers correctly. And part C, less than 3 answers correctly. Okay, so this is what we're going to do. There's 3 questions. I'm going to look at question A. It says exactly 3 answers correctly. So this thing is asking for us to remember 5, choose 3. There's 5 questions and I want 3 of them correctly. Before I move on, let me just say that this thing we call this probability of 3. Right, the probability to get 3 correct, we're gonna call this 5 choose 3. And then my p-value, remember 0.25. Let me go 0.25 to the third because I want correct 3 times. And then 0.75 to the second because I'm going to be wrong 2 times. And then I'm going to type this on my calculator, but let's remember 5 choose 3. 5 choose 3. I'm just going to call that 10. 5 choose 3. Again, I call that 10. So I'm looking at this as 10 times 0.25 to the third times 0.75 to the second. You guys might be wondering, how did I get the 10 from the 5 choose 3? Okay. If you need a reminder how to do choosing, so 5 choose 3. How did I get a 10 out of that? Well, I went 5 factorial on the top. I was looking at a fraction, 5 factorial on the top, and at the bottom I have 3 factorial. You see where I got the 5, you see where I got the 3. But I also subtracted those two numbers, 5 minus 3. I know 5 minus 3 is 2. So at the bottom, I'm also going to have a 2 factorial. Now, 5 factorial is basically 5 times 4 times 3 times 2 times 1. 2 factorial is basically 2 times 1. And 3 factorial is 3 times 2 times 1. So now, when I multiply my numbers on the top, I get 120. When I multiply my numbers at the bottom, let's see, I'm going to go 2 times 1 times 3 times 2 times 1, I get 12. 120 divided by 12, that's 10. So that's how I did the 5 choose 3, I got 10. Okay, so that was a reminder how to do choosing. Okay, so now this, I just type it on my calculator, 10 times 0.25 to the third times 0.75 to the second. And my answer here is going to be 0.087891. Now, how do we type this? Well, I'm going to ask you to round it to either 2 decimal places, 3 decimal places, 4 decimal places. Here, I'm just going to run it to 6, okay? I'm going to run it to 6, but on the answered, I will ask you how much to run this answer to, okay? Part A was not bad. Let's take a look at part B. Part B is asking at least 3 answers correctly. Okay, so that's basically asking me, what's the probability that I get 3 answers correctly? What's the probability I get 4 answers correctly? What's the probability I get 5 answers correctly? Because it said at least 3, so 3 or more. Now, probability that I get 3 answers correctly, just as a reminder, I know we have the answer to this already, probability of 3, but just as a reminder, I went 5 choose 3 times 0.25 to the third times 0.75 to the second. And this thing gave me 0.087891. Okay, that's 3 correctly. Now that's the probability I get 4 right. Well, I'm gonna go 5 choose 4. But in this case, I'm gonna go 0.25 to the fourth, because I want to be correct 4 times 0.75 to the 1, because I want to be wrong only once. And this thing is going to give me 0.014648. Now, what's the probability I get 5 right? Well, I'm going to do 5 choose 5. In this case, I'm going to go 0.25 to the fifth, because I want to be right 5 times 0.75 to the 0, because I want to be wrong 0 times. And this thing gives me 0.000977. Now, when I add all this 3, I'm going to get 0.103516. Okay, not bad. And let me go to black for part C. Part C says less than 3 answers correctly. Now, couple things I can do. I can find out less than 3, so I can find out what's the probability that I get 0 right, what's the probability I get 1 right, what's the probability I get 2 right, and then add them up. Right, what's the probability I get 0 right? Remember, I had to go 5 choose 0, and then I had to go 0.25 to the 0 times 0.75 to the fifth. What's the probability that I get 1 right? Well, 5 choose 1. In this case, I'm 0.25 to the 1 and 0.75 to the fourth, because I'm going to be 1 correct and 4 wrong. And then what's the probability I get 2 right? 5 choose 2, and then times 0.25 to the second times 0.75 to the third, because I'm going to be right twice and wrong 3 times. And then add them all up. Right, each of these gives me a number, add them all up, good to go. Now, there's one way. Another way we could have done this, because when I combine all my possibilities, my probability is 1. So basically saying probability of 0 plus probability of 1 plus probability I get 2 right plus the probability I get 3 right plus the probability I get 4 right plus the probability I get 5 right. When I add all my probabilities is equal to 1. So I can just say I want to take away the 3, 4, 5. So I can just say 1 minus, and as a matter of fact, let me just say here, probability of 3, probability of 4, probability of 5. I'm going to show you guys the 1 minus. Because if we could have done that at the top, find the probability of 0, probability of 1, probability of 2, and add them up, and you're done. However, I can also do this other method. I can do 1 minus the probability of 3, probability of 4, probability of 5. I know this is basically asking what is 1 minus 0.103516. You guys might be wondering, wait a minute, where did this decimal come from? Isn't that what we did on part B? We did probability of 3 plus probability of 4 plus probability of 5. We added them up. So I'm just looking at what's 1 minus 0.103516. And then my result in this case will be 0.896484. Wow, that's a big probability. It's about almost 90%, right? 89.64%. Wow, so almost 90%. If I take just 5 questions, multiple choice, 4 possible questions, and I randomly guess, not almost 90% sure that I get 0, 1, or 2 right only, not more than 2. Wow, guessing is not worth it. Okay, now about a surgery. Let's take a look at here. There's a surgical technique. It's performed on 7 patients. Now you are told there's a 70% chance of success. Ooh, okay. Let me write some information here. I'm gonna say my p-value is 0.7, or you can call it 0.70. It's the same thing, right? Succeed is 0.7. So Q, my failure, is gonna be 0.3. 30% failure. Find the probability that the surgery is successful for exactly 5 patients, at least 5 patients, and less than 5 patients. Okay. Again, let me look at this as 3 questions, A, B, C. So my A, it says exactly 5 patients. So what's the probability that 5 patients, exactly 5? So how does this look like? Remember, there were 7 patients, so I'm going to say 7, choose 5 times 0.7 to the 5th, because I want 5 patients to be correct or successful, and 0.3 to the 2nd, because I want 2 of them to be not successful. Okay, using a calculator. Okay, so I'm going to use a calculator in my case. Using a calculator, probability I get 5 right is 0.317652. Okay, not bad. My question B, it says at least 5 patients. Okay. So for question B, at least 5. So that will mean what's the probability I get 5 people correct? What's the probability I get 6, or probability of get 7? So for probability that I get 5 right is 7, choose 5, 0.7 to the 5th, and 0.3 to the 2nd. And that gives me 0.317652. Now, what's the probability I get 6 patients, right? So remember, I'm going to go from the 7, I'm going to choose 6. In this case, I'm doing 0.7 to the 6 times 0.3 to the 1. According to my calculator, that gives me 0.247063. As a reminder, feel free to pause this video anytime just to type this information in the calculator to make sure you guys get the same numbers. Now, as a probability I get 7, right? I'm gonna do 7, choose 7. So I want 0.7 to be 7 times 0.3 to be 0 times. Again, feel free to pause this video anytime. Now this thing gives me 0.082354. When I add them all up, I get 0.648255. Okay, not bad. Let's take a look at part C. Less than 5 patients. Okay, so I can do this 2 different ways, right? Less than 5 patients. I can find out what's the probability of 0 patients, plus probability of 1 patient, plus probability of 2 patients, plus the probability of 3 patients, plus the probability of 4 patients. Add them up, and that's my answer. That's one way of doing this. Another way I could do this is I can go 1 minus, in a group, I'm gonna have probability of 5 plus probability of 6 plus probability of 7. I know I'm gonna use this method instead because I'm gonna go 1 minus. I know that's a probability of 5 plus probability of 6 plus probability of 7. I know that is 0.648255. How do I know? Because I just did it on my previous example in part B. Now this is easy. 1 minus 0.648255. Use a calculator. I happen to get 0.351745. I could have done probability of 0 plus probability of 1 plus probability of 2 plus probability of 3 plus probability of 4. Combine them all and good to go. But I'm going to do it this way instead.